All right, calculator section number 1. Group of monarch butterflies migrated from Chicago to Mexico, flying a total of 2,100 miles. It took the single butterfly 120 days to do this. So on average, how many miles did they travel per day? All right, per day there. So I think we can just divide these two numbers. We have 2,100 miles in 120 days. And if you want to find out for one day, you can divide those two numbers out. And I believe you get 17.5. Another method is to set up a proportion. And it's basically the same process, but you have 2,100 miles in 120 days. And then that would be equivalent to how many miles in one day. And then you could set up a equation by cross multiplying 120x times 2,100 and basically divide both sides by 120. And you'll notice it's the same exact thing that we did over here. We just set it up a little more formally with a proportion. Number 2, chemistry experiment. 3 beakers containing different amounts in milliliters. The 3 beakers are, so we have a 120, we have a 340, and we have a 275. And these are mLs. What is the approximate total number of ounces in the 3 beakers? So we're looking for ounces in all 3. So first let's add these up, and we find out that that comes out to be 735 mLs. And now we need to do a little conversion. If 1 ounce is 29, almost 30 mLs, how many ounces would that be total? If you see a shortcut, you could probably just divide 735 by 29.57, and you could zip right to the answer that way. For some kids, it's easier to set up a proportion here. So you could say, hey, 1 ounce is 29.5735 mLs. So that means how many ounces would be 735 mLs. And then you could also set up an equation. You could cross multiply. And you get 29.5735 equals x there equals 735. And then just divide both sides by the 27 number. And either way, you should come out and you should get the same answer, which was 24.85, which would be D. Number 3 just looks like an algebra equation. 3/4 x plus some ax equals 10. In the equation above, it says a is a constant. So remember, whenever they say that, a constant just means it's a number. It's not a variable. It's not going to change. It's just a regular old number. If x equals 24, so there's our clue to the solution, what is the value of a? So that means we want to substitute 24 in place for x. So I'm going to rewrite this. 3/4 times 24 plus a times 24 equals 10. And depending on your fraction skills, hopefully you have a calculator that can do fractions. Strongly suggest that. I'm going to normally do them by hand in my videos because I'm kind of old school like that. So I'm going to divide or multiply here and put a 1 on the bottom. So 3/4 times 24 over 1. I'm going to cross cancel. 4 goes into itself once. 4 goes into 24 6 times. Now I multiply straight across and I get 18 over 1. Plus a times 24 is just 24a equals 10. Now I'm just going to solve a 2-step algebra equation. To get a by itself, I'm going to minus the 18 to both sides. And that gives me 24a equals negative 8. And then to get a by itself, I do the opposite of times. I divide both sides by 24. And don't put this in your calculator because if you kind of take a peek at the answers, they're all as fractions. So we basically want to reduce this negative 8 over 24. And 8 goes into both those numbers. 8 goes into the top number, negative 1. 8 goes into the bottom number, 3. So final answer is B, negative 1/3. All right, number 4. They give us some sort of equation here at the top. Let's read the paragraph and kind of see what the letters represent. The formula above can be used to approximate the daily energy requirement C, which is calories. All right. So right here, this is how many calories that an adult dog needs in a day, and it's based on W, which is the weight. So it kind of makes sense. If a dog weighs more, it needs more calories each day. So based on the formula, if a dog has a daily energy requirement of at least 1120, at least means equal to or more than 1120, and at most 1216, which of the following inequalities represent the range of all the values of the dog's weight to the nearest tenth of a kilogram? So basically, we need to kind of figure out what W is when C is these two different values. So the first thing is I'm going to plug in 1120 calories. So I'm going to solve an equation where 1120 equals 1.6 multiplied by the quantity 30W plus 70. And I'm going to solve that equation first, and that should give me my lower range for weight. So we go ahead and I like to distribute first here. So 1.6 times 30, that's 48. 1.6 times 70, that comes out to be 112. Forgot my W there. Equals 1120. And now we basically got to solve this equation. So I'm going to minus the 112 from both sides. Minus the 112. And I end up with 48W equals 1008. And then dividing both sides by 48, I get an answer of 21. So what that basically meant was a dog that weighs 21 kilograms requires 1120 calories. Now, peeking at my answers, I see right here I have a 21, and I feel pretty good. You know, on the test, I would probably go with this answer and just move to the next question. But I do want to verify that the other number for 1216 comes out to be 23. So let's just kind of take a quick look at that and make sure that it does what it's supposed to do. If you had this all on here, you could actually save a little bit of work, because we have 1216 equals the 1.6 times 30W plus 70. And you could use your answer from before. Remember, this was 48W plus 112. And you just kind of have to resolve the last part of the problem. So I'm going to minus the 112 from both sides. Minus 112, minus 112. And basically I get 48W equals, that's 04, so that'd be 1104. Divide both sides by 48. And we get 23. So we verify that, yes, this is the correct range for the dog's weight in kilograms. All right, number 5, they give us a table, and then it looks like we're going to have to match it up with some graphs down here at the bottom. So it says we have China in 2010, India, Brazil, Nigeria. The table above shows the population of 4 countries, and then the projected population in 2050, so 40 years later. If the population of each country were to increase at a constant rate, okay, if you increase at a constant rate, that means you're linear. You form a line. As opposed to a lot of populations kind of grow slow and then they end up getting faster and faster, which that would be exponential growth. This is linear growth, constant. Which of the following graphs would model the populations? So let's kind of compare these guys. So China starts at 1371 and goes to 1437. So there's definitely an increase, but not a huge increase. If you compare that with India, India started lower at 1150 and it actually finished higher. So, you know, kind of visualizing this in my mind, China did grow, but India started lower and grew faster and grew to a higher amount. So I'm kind of looking for an answer that has that going on. So it looks like A could work, you know, B could work. C, definitely not, because that shows that China went down. China did not go down. D shows that they both went up, but it didn't show India crossing China. So right now I can wipe out 2 answers and I at least have it down to a 50-50. So it looks like we got to go further and we got to take a look at Brazil and Nigeria. So Brazil definitely increased. So we're going up. We go from 193 up to 260. So that is Brazil. And then if we look at Nigeria, we started lower. So we'll put it maybe down here at 160. But we finished higher. So kind of the same situation. Nigeria surpasses Brazil up to 299. So that one looks like the correct answer here would be A. Now B is a little bit tricky. A lot of people put B because Nigeria does overtake Brazil. But the problem was Brazil did not decrease or go down in population. It still was going up. The other one just went up a little bit faster. So correct answer for that problem is A. Number 6, you'll find this chart on the same questions for 6, 7, and 8 because all 3 questions kind of operate off the same information. So let's jump into this first one. It says, for quality control, a company that manufactures light bulbs conducted 5 different trials. In every trial, there were 500 light bulbs tested. And then the bar graph shows how many were defective. So in this first trial, we had 4 defective bulbs, 7 defective, 1 defective, 3 defective, and 6 defective. So it says, what is the mean number of defective bulbs? That's just the average number of defective bulbs. So for the average, I'm going to add them all up and then divide by how many trials there were. So if we add up the light bulbs here, it looks like we ended up with 11, 12, 15. We had 21 defective light bulbs. So we had 21 light bulbs that were defected, divided by the 5 trials. So 5 goes into 21. It looks like 4.25 defective per trial. That was our average. And the closest one to that would be choice B with 4.2. So they didn't have the exact answer. You kind of had to pick the closest answer. So number 7, the same chart as number 6, but a little bit different question here. So it says, what is the ratio? So remember, a ratio can either be a fraction, so you'd say like the ratio of A to B, or you can write it with a little dot in between. Those both represent a ratio or a comparison of 2 numbers. So the ratio of defective bulbs in trial D, so that's right here, compared to the median number of defective light bulbs for all 5 trials. So remember, median is the middle number, and you have to put them in order from least to greatest before you can find out, what the middle number is. So kind of looking up here at our information, we're going to focus on D here. Well, D has 3, all right? So we want to do the ratio of the number of defective light bulbs in D. So 3 is the defective in D, compared to the median. Well, let's line these numbers up and find the median. So the numbers are 4, 7, 1, 3, and 6. So putting them in order, we go 1, 3, 4, 6, and 7. So this is the median number, would be 4. So if you look up here, what I have is I have the defective for trial D compared to the median defective. And so that's 3 to 4. So the correct answer for this one would be D. All right, number 8, last question about these defective light bulbs. See what they're asking. It says in trial B, so my focus needs to be right here, in trial B, what percent of the light bulbs, so we need a percent here, were defective? So it looks like there were 7 tested. So 7 out of 500. So there's kind of a shortcut here. Whenever you want to find the percentage and you know the part and you know the whole or the total, you can just divide those numbers. And if you do 7 divided by 500, it comes out to be 0.07 0.014. And whenever you want to change a percent to 100, or change a number, a decimal to a percent, you multiply by 100, or just move it 2 places. So this would come out to be 1.4%. Now some people like to use what's called the percent proportion. Now I'll show you that one as well. The percent proportion is 2 fractions, and basically you always set up the part over the whole, or the total, equals the percent over 100. And the 100 is there for every problem. The nice thing about this one is you don't have to worry about moving decimals around. So if you're going to use this one, you set it up and you say, well, the defective part is 7 out of the whole, or the total was 500. And that would be what percent out of 100? And a couple different ways you could do this. If you wanted to, I mean, the hardcore way of solving proportions is just cross multiply. And you could do that and do this. And so multiply both of them, and then divide both sides by 500. And divide by 500. And you'd also get x equals 1.4. And you wouldn't need to worry about moving the decimal. That percent proportion, it's already built in. That's why the 100's in there. So you could do it that way. Some people also might do the proportion differently and see that, oh, to go from 500 to 100, I divide by 5. So you could also divide the 7 by 5 and get 1.4 that way. There's lots of ways to do it, but the absolute fastest way is what we had up here at the top. All right, number 9, just glancing at it. I kind of always peek at the answers before I start the question just to kind of see where I'm going. What do I really need to solve for? And if I kind of look at all of these answers, I notice that they're all systems of equations. So this is an advanced algebra concept. But it looks like I don't have to solve anything. I just have to set it up. So let's check it out. On a certain day, air traffic controller determined the number of airplanes that took off from runway M was 3 times the number that took off from Q. So basically translate that. M is 3 times Q. So I'm going to set that up with an equation. M equals 3Q. And that will guarantee that runway M has 3 times the number of flights that Q does. And you could put some numbers in there just to make sure, you know, like let's say that there were 10 flights on Q, then that means we're going to have M would be 30. So I can kind of verify with some play numbers just to make sure that my equation's set up right. And then on that same day, a total of 120 airplanes took off from the 2 runways. All right. So when you add up the 2 runways together, it came out to be 120. So the M flights plus the Q flights came out to be 120 total flights. So I now have my systems of equations. If I needed to solve 2, I could. We have some different methods for that. But the correct answer for this one would be A. Now, when I look at the data for the state, it looks like the most common wrong answer was B. And I think it's because of this setup in the beginning where it says if M was 3 times bigger than Q. A lot of people confuse that and think that this is the way you write that. And you can't write it that, you know, if M is 3 times bigger than Q, put some numbers in here and see what works. You know, if I pick that number 10 and I put it in, that means if M has 10 flights, then Q had 30. All right, so that wouldn't work because then Q would be bigger than M. And if M is 3 times larger, then you have to set up the equation so it comes out that way. So just be careful that you don't get the coefficient 3 there switched up. All right, number 10, talking about cheese production, and this is another kind of multi-part problem because 10 and 11 both operate off of this cheese chart. So over here on the side, we can kind of read, and it says that the production of cheese is over here on the left, and that's in millions of pounds. So every number there needs to get multiplied by 1,000,000. And then here are the countries down on the bottom that produce them. If I could spell the word countries. And they're comparing it to Wisconsin. So it says in 2012, Wisconsin produced 951,571,000 pounds of mozzarella cheese. So they produce a lot of different types of cheese, but I guess this much was mozzarella. So which of the following is closest to the percent of, so this gives me my bottom number. Percent of always helps me establish the bottom. The Wisconsin cheese production, that was mozzarella. So I want to compare how much mozzarella to the total cheese. You know, you're talking cheddar, Swiss, Munster, all the different types. So we look on the chart here, and it looks like Wisconsin produces 2790. So 2790. But remember, that's in millions. So I need to add a 1 with 6 zeros there. So basically, you can take that number and you can just add 6 zeros to it instead of messing around with your calculator. So let's do this. We got mozzarella cheese, 951,571,000. That is our part we're looking for. So we're looking for the mozzarella part compared to the total cheese, which here we go. This is a big number. 2790, 1, 2, 3, 4, 5, 6, because we're in millions. So that's a 2 billion number. So I need to divide those out, and I'm going to punch that into my calculator. And I get, let's see here, 951,571 divided by 2790, 1, 2, 3, 4, 5, 6. And it's looking like roughly 0.34. So move that 2 places to get our percentage. We're looking at about 34%. So the correct answer for that one is going to be C. All right, number 11, second part of the cheese question. Same information, but let's see what they're asking for this one. It says, of the following, which best approximates the ratio? So here I'm going to compare the two numbers, and it looks like they're in dot dot format. So I'll kind of set mine up that way. So we want the ratio of cheese production in the U.S., excluding Wisconsin. So I believe that's this column right here. So I have 8100. And then I'm comparing that to, so 2 is kind of where my dot dot falls in, Wisconsin in 2012. So Wisconsin in 2012 was here. So now when I ratio these two numbers out, well, first of all, the first number is larger than the second number. So that wipes out A and B because 1 is smaller than 3 and 2 is smaller than 5. So the ratios kind of have to stay in order like that. Now we basically have to decide, is it a 5-to-2 ratio or a 3-to-1? I believe this looks more like a 3-to-1. If I multiply this number here on the right, 2790 times 3, let's just see if that comes out. 2790 times 3. And I get 8370. So if I times this number by 3, I get 8370. And that's pretty close. Otherwise, if I multiply this number by 2.5, because that's what a 5-to-2 ratio means, you multiply by 2.5. So if I got 2790 times 2.5, that only comes out to be 6975, and that's quite a bit short. So I think this number looks a little closer. So I'm going to go with D. I'm going to go with 3-to-1 ratio. Another way to kind of compare these ratios out, if that one didn't quite sink in really well, is, you know, a 1-to-3 ratio is basically 1 divided by 3, which you can get a decimal for that. You'll get 0.33. 2 divided by 5, you'll get 0.4. 5 divided by 2, you'll get 2.5. And then 3 divided by 1 will give you 3. So I have these different ratios or these different fractions. And earlier we were comparing, you know, the total cheese by the U.S., not counting Wisconsin, compared to Wisconsin. And if you just divide those, I mean, that's what this bar means divide. If you just divide those out, 8100 divided by 2790, you're going to get 2.9. 2.903, and then a whole bunch of other numbers. And then you kind of have to ask yourself, which number is that closest to? So coming down here and comparing, definitely no, definitely no. 2.5 kind of close, but much closer to 3. So that's kind of another way to pick which ratio is. Just divide them out. Put the first number on top and the second number on bottom, and divide it and get decimals. It's another way to kind of look at ratios. Number 12, because I'm looking through my school, I have access to the test here, and it's a little bit different format than what you see on the actual test day. So you'd probably notice, and when you're analyzing your data through the College Board, you may notice that the question looked a little bit different than on the original day. This was probably in a chart. So you kind of have a line coming right here. You have a line separating right there, and then probably another line coming here. So how I read this chart, you're looking at state parks, and they have camping facilities or bicycle paths. So you have kind of two factors going on. The big idea, and the Khan Academy has some really good practices on these. This is called table data. So if you look at table data on the Khan Academy SAT practice, you'll find a lot of problems like these, and they're very good as far as they resemble a lot like what the SATs look like. There are some topics that I really don't like the Khan Academy problems. I don't think they represent very well what we've seen on the actual tests, but these ones are pretty good. So here's how I read these. You always want to kind of put your totals going horizontal and vertical. So for instance, just focusing on these camping facilities, there are 20 parks that have camping facilities, and then there's 5 more that have camping facilities. So there's a total of 25 that have camping. Do not have camping, you have 8 plus 4. So you have a total of 12 that has no camping. All right, so I kind of went horizontal. Adding these two numbers together, you're going to get 37. So there are 37 total parks. Now, they didn't give you this in the question. You have to come up with that on your own. So that's kind of knowing how these tables work. So now if you kind of focus on the vertical aspect, parks that have bicycle paths, well, there's 12 and 8, or there are 28 parks that have bicycle paths. And then there are 5 plus 4, there are 9 that do not have bicycle paths. And again, when you add going across, you get 37. So from both directions, you should get the same number, and that'll give you the total for the problem. And that becomes pretty important depending on the question. So this question here says, if one of these state parks is selected at random, so any one of the parks selected at random, so that means there were 37 possibilities. So out of the 37 total parks, what is the probability, or what is the chance that it has camping? So this is my has camping row right here. So those 25, but does not have bicycle path. So according to the chart, the number that has camping is the top row, not bicycle is the second column. So right here is the one that fits the bill for that. So 5 out of the 37. I'm going to clean this chart up a little bit and just explain, because I got a lot of lines on here. All right, the first part was just trying to figure out how we knew that there were 37 total. But when they say, what is the probability? Probability is always a fraction. And the top part has camping but does not have bicycle. That's going to be what goes on top. So we had have camping, not bicycle, goes on top. The total goes on the bottom. And we could get a percentage, but they just represent the answer as 5 over 37. If this was a percent question, okay, just kind of showing you that, if it was, you would divide these two numbers out and go 5 divided by 37, and you would get 0.1351, aka about 13.5%. All right, so they may ask you probability as a fraction, they may ask you probability as a percent, but be sure that you can do either one. All right, number 13. You might notice that on the real test, the actual test, it was set up a little bit differently than this. On the College Board, they kind of don't really put it in the same format, and it looks a little bit goofy. So I'm going to put in some lines here of what it probably looked like on the real one. They probably had this in some sort of a table, and the sample size, there were 2,500 men. The average height, remember mean means average. The average height was 186 centimeters, and the standard deviation was 12.5 and 19.1. I want you to think about standard deviation as a concept known as spread, how the data is spread out. So data spread out. And I'm going to kind of go off the grid to give you just a little quick example of this, and maybe it'll make more sense. So let's say that you have a bunch of data, and let's assume it follows like a normal bell-shaped curve, and you kind of come out and you kind of go up and then you come back down. All right. Well, let's say these are heights, and 186, that was our average centimeters, is in here, but we had all kinds of heights. We had all kinds, quite a few right around the middle, and then right out here. All right. So that has a certain standard deviation. Well, maybe in another population of people, in that other 2,500, our curve, it has the same average there, but let's say that it goes way up like this and way back down. So that means that there was a bunch of heights very, very close to that 186, but very few as you went further out. So the data is really tight. All right. So when the data is tight like that, you have a low spread. That means you're going to have a lower standard deviation. And up top, the data is a lot more spread out. Even though the average was the same, you have more spread. So you have a higher standard deviation. Standard deviation kind of has this weird little Greek letter here, but you don't really need to know that. So which of the statement is true? Well, group A was identical to group B. That is false because the data was spread differently. So in my example, this one here would be kind of the spread out one, where this one here would be a little bit tighter. Group B contained the tallest person. We don't know that. All we know is the average and how it was spread. Part C, the heights of the men in Group B had a larger spread. Group B, bigger standard deviation, larger spread. That is your correct answer. Let's just look at D. The median or the middle height is larger. We don't know that. We don't know anything about the median because we were talking about the mean or the average. So big idea is when the data is spread out, you have a higher standard deviation. All right, number 14, just kind of peeking at this. It looks like we have a function notation. So this is P, kind of read this the way it goes up here. This is kind of P in terms of M. And let's see what P and M mean. The function P above models the total price, M in dollars, of streaming M movies. So M is the number of movies per month on an online movie subscription service. The service charges $8 monthly fee, so that's a flat fee. All right, so that's what this number represents, the $8 flat fee. Plus you get an additional fee per movie. So it looks like to me, if M is the number of movies, it looks like they're charging $2 per movie plus an $8 fee. So if I kind of put this thing into a chart, let me just kind of come over here. So P of M equals 2M plus 8. Well, the price if I stream one movie is 2 times 1 plus 8, which would be $10. And I'll go another one. The price of 2 movies is 2 times 2 movies plus the $8. So that's 12, and so on and so forth. So it says, which of the following is the best interpretation of P parenthesis 10? Well, P of 10 means that it's going to be 2 times 10 plus 8, which is $28. $28. So What does P of 10 represent? What is this? Well, P of 10 is going to be when 10 movies are streamed per month, the total price is $28. So the correct answer there is going to be D. So it's just a matter of interpreting the question, understanding what's going on, and reading and making sure you know that 10 represented the number of movies and P was the total price. All right, number 15 is definitely the part on the PSAT where I think they start to kick it up a notch. The problems become quite a bit more difficult. And here might be a spot where when you look at this, if within 10 seconds, 20 seconds, you don't have a clue on how to get started, I would skip it and go to the next question, because you don't want to miss easier questions that maybe are in your wheelhouse later on. So don't spend too much time on any one question. You can probably always come back to it if you have time later. But let's tackle this one. So I noticed that I have two fractions subtracted from each other, and their bottom numbers, their denominators, are really close. They're not equal, but they're pretty close. So just kind of a quick review with fractions. If I do like 4/5 minus 1/5, remember when you subtract fractions, you subtract the top numbers and you keep the bottom number the same. So the answer would be 4/5. Now, if the bottom numbers weren't the same, let's say you had 3/4 minus 1/3. Well, now you can't subtract straight across because you have different bottom numbers. So what you're going to have to do is you're going to have to figure out a common denominator for both of those. So if I was doing this by hand, I realized that 4 and 3 both go into 12. So I would change these both into 12ths. And then I would kind of use a little maneuver to scale it up and say, well, I got to multiply 4 by 3 to get 12. So I also have to multiply the top by 3, and that would be 9. Here I multiply the bottom by 4, multiply the top by 4, and now I could subtract these two questions, and I would get 9 minus 4 is 5 12ths. All right. Now, another way to kind of see that process is, at least that's the way I do fractions by hand, another way to kind of see that process is you can just multiply each fraction by the other denominator. So, for instance, this denominator is 3, so I can multiply this side by 3 times 3 because it's just 1, and multiplying by 1 doesn't hurt anybody. And then I multiply this fraction by that number on top of itself, by 4/4. And that'd be another way to get 9/12 minus 4/12. Okay, so I'm going to kind of use that idea here. And when I look at this fraction up top, I notice that they're the exact same except for this one has a 3 in front of it and this one has a 2 in front of it. So here's going to be my goal. I'm going to multiply this fraction here on the right by 2/2, by that number. And then I'm going to multiply the fraction on the left by 3/3. And then we'll worry about subtracting them in a minute. So let's kind of do this first part. So let's multiply over here. 3 times 4x is 12x. And on the bottom, I'm going to have 6 times x squared minus 1. And then subtract. And now over here on the right-hand side, I'm going to have 2 times 3x, which is 6x, over, and then 2 times 3 is going to be 6 times, parentheses, x squared minus 1. Well, now I'm in pretty good shape because I have two fractions with a common denominator, and I can subtract these two out. So I subtract the top, 12x minus 6x is 6x, over the bottom, which I just keep the same. Remember, when you subtract fractions, you keep the bottom number the same, just like we did over here. And now I can cancel out my 6's. I can just kind of come in and say, hey, let's wipe out the 6 on top and 6 on bottom. And what you're left with is x over x squared minus 1. So that one will be D. Now, that's the fancy way to do it. That's the algebra way to do it. If you suck at algebra, but you want to still have a shot at getting this question right, let me show you another way. It could be more work. It might be less work. But I'll show you what I do on a lot of, this is one of my biggest strategies, what I'm going to show you right here. How you can out-slick problems and show that you're actually smarter than you maybe really are. Although I call it pretty smart if you can out-slick the problem and kind of cheat it a little bit. So here's what I'm going to do. I'm going to pick my own x. I'm going to pick an x. But it says x cannot be -1 and x cannot be +1. So those two numbers are out. I can't choose those. And that's because the denominator would have been 0 over here. You're not allowed to divide by 0, but who cares? Don't worry about that right now. I'm going to pick an x, and I like to pick small numbers. I'm going to pick 2. All right? So I'm going to just pick x equals 2. And I'm going to plug it in. So on the top, I'm going to have 4 times 2. So I'm just basically plugging x equals 2 into that. So 4 times 2 over 2 times 2 squared minus 1. And then take away 3 times 2 over 3 times 2 squared minus 1. And what I'm going to do is I'm going to see what answer that gives me. And whatever answer that gives me, my A, B, C, or D has to give me the same answer when I put 2 in. So let's see what we got. When I simplify this down, this first one is 8 over, that's 2 times 3, which would be 6. So 8 over 6 minus, and then over here I'm going to have 6 divided by 3 times 4 minus 1. 3 times 3 is 9. So I have 8/6 minus 6/9. Now, if you have a calculator, you can just punch in 8/6 divided by 6, or subtract 6/9. I don't have a calculator right here, so I'm going to just go ahead and do it old school. I'm going to pick 18 to be my common denominator. So I'm going to choose 18s for both of them. And 6 goes into 18 3 times. 3 times 8 is 24. 9 goes into 18 twice. And 6 times 2 is 12. So final answer, 24/18 minus 12/18 is 12/18. Now you could also reduce that down. 6 goes into both these numbers. If I divide them by 6, I get 2/3. So more of the story here is, if x equals 2, all right, if x equals 2, then I should get an answer of 2/3. So that's what I'm trying to make happen over here in all of these choices. All right. And I'm not going to go through and show you all of them, but I'm going to show you one that doesn't work and one that does. So like in number 1, if I use that fact of x equals 2 and I plug it in, 1 over 6 times 2 minus 1. Well, that is 1 divided by 6. And that is not equal to 2/3. So you're gone. I'll try another one. 2 over 6 times 2 squared minus 1. Well, that's 2 over 6 times 3, which is 2/18, which is not equal to 2/3. And I guess I might as well do them all. This one's pretty easy. 1 over 2 take away 1. Well, that's 1. And that's definitely not equal to 2/3. And then if I put in the very final one, I get 2 over 2 squared minus 1, which is 2/3. So I can also get the correct answer D with doing 0 algebra, but picking an x, plugging it in until I got an answer to match up. Anytime you see this, and you're going to see this multiple times on an SAT, which of the following is equivalent to the expression? So they're basically wanting to know this guy equals which one of these guys. You can pick a number and plug it in and kind of out-slick the problem. Good strategy. All right, number 16, in the XY plane, a line contains the points 2, 6, and 8, 10. So just a quick little refresher. Remember that these are coordinates x, y, x, y. And remember that the coordinate grid or the coordinate plane, the x goes here and the y goes there. Which of the following is the equation of line L? Well, I peek at the answers and I notice all of these guys are in what's called slope-intercept form. Y equals mx plus b. And this m represents the slope of the line. And this b represents where you cross the y-axis or the y-intercept. So a couple different ways I could do this problem. I don't know. First thing is, I noticed they all have different slopes. This line has a slope of 8, slope of 2, slope of 3/2, slope of 2/3. So if you want to, you could use, the fastest way would probably be to use the slope equation. Slope equation is basically, so slope is the change in y, that's a Greek letter delta, means change, over the change in x. And to find change, you subtract. So if you look this up on the internet, it would say y2 minus y1 over x2 minus x1. The ones and twos just mean like this was the first order pair and this was the second order pair. So putting numbers in, y2 take away y1, and then x2 take away x1. Well, that gives me an answer of 4 over 6, which when you reduce that, you get an answer of 2/3. So I am thinking right now that this is probably the correct answer. Matter of fact, I know it is. Now, if you forgot the slope equation, you could also just say, hey, well, why don't I just graph these 2 points? And I'm going to go 2, 6 is going to be 1, 2, 1, 2, 3, 4, 5, 6. So right there is at 2, 6. Whoa, don't know where that came from. Looks like it came from a problem that I had on there earlier. So we got 2 6s right here. And then if I do another one and I do 8, 10, so that would be 3, 4, 5, 6, 7, 8. And then we were already at 6, 7, 8, 9, 10. So over 8 up 10 is going to put me right there. So here's my line. And I'm going to kind of just keep on coming down and kind of do something like that. Well, I can see from these 2 points, some of you guys might remember slope as being rise over run. That's another thing that people say, oh, slope is rise over run. So to get from this point to this point, my rise, I basically rose 4. And then I ran from 2 all the way to 8. So I ran 6. And a slope of 4, 6 to kind of reduce that is really go up 2 over 3. Up another 2 over 3, and it'd be the same thing as 4, 6. We'll also notice that our back number worked out the way it was supposed to. 14 divided by 3 is like 4 2/3. And I do cross, it looks like I crossed the graph at roughly 4 2/3, which is where I should be. I definitely didn't cross way down here at -2. I definitely didn't cross up here higher at 6. And I definitely didn't cross all the way up here at 10. So multiple ways to get that question right. But I think the fastest way is to probably just use the slope equation. I think this would have been the quickest way to get this problem correct. Now another way you could kind of outslick this problem is if you really don't know a whole lot about slope or about graphing or what the graph's going to look like, if points line on the graph, when this says line L contains the points, that means that if you plug x equals 2 and y equals 6 in, it works. All right. And also, if you plug in the combination x equals 8, then you get y equals 10. That should work too. And they make this one hard to do because they use some weird fractions to make it harder to plug in and see what happens. But it could be done. I'll just kind of show you maybe why a couple of these would not work. Because if I plug 2 in, do I get 6? Well, if I go here, if I stick a 2 in there, I get 2 times 2 plus 6. Well, that equaled 10. All right. So 10 was here, 2 was there. That's not a pair. You're supposed to get 2 and 6. So that wouldn't work. If I tried it down here at the bottom, if I plugged x equals 2 in, that's 16 plus 10. Well, that does not equal 6 either. That equals 26. So I know this wouldn't work. So you could also start plugging in the ordered pairs and see if they work. It takes a lot longer, but it could get you the right answer. All right, number 17 says if x is not equal to 0, which of the following expressions is equivalent to blah, blah, blah. So I think what this one is mainly testing is the law of exponents. This part right here just says, hey, the denominator You can't have 0 because then you're going to have, over here you're going to have something divided by 0, which is not allowed. It's undefined. You'll get an error. So don't sweat that first part too much. Basically, we need to whittle down this piece over here. So you can kind of break this up separately and say, well, what's the square root of 16 times the square root of x to the 4th times the square root of y to the 8th. In your mind, you can kind of break it up separately like that, all over x to the 3rd. So, the square root of 16 is just 4. And the square root of x to the 4th, well, that's basically saying, what times itself equals x to the 4th? Well, x squared times x squared will give me x to the 4th. So this is really just x squared. And then this last part, the y part, is, what times itself equals y to the 8th. That's what the square root's asking. Well, remember, when you multiply powers, you add the exponents. So this is really y to the 4th times y to the 4th will give you y to the 8th, because you're supposed to add the exponents. That's the rule. So this is just y to the 4th. So now let's clean this up. I have 4x squared y to the 4th all over x to the 3rd. Now, I'm going to kind of repeat this process again. I'm supposed to, so another rule is if you divide powers. So for instance, I'm going to put this in a thought bubble because this is not part of the problem. But if I have like x to the 10th divided by x squared, well, that's really x to the 10 take away 2. So the answer would be x to the 8th. A lot of people would screw that up and actually think it was x to the 5th because they would accidentally divide. But you subtract the exponents. So when I'm looking through here, this is really 4x to the 2 minus 3, and then y to the 4th, which is really 4x to the negative 1, y to the 4th. You end up with a negative when you subtract those exponents. So the correct answer here would be D. Sometimes I just cancel out. So like I might have not have done it that way. I might have just up here on the top, and said, well, x squared is really x times x. And on the bottom, x to the 3rd is really x times x times x. And then I just kind of cancel them out. And I'd say, well, I cancel these two out, and I have 1 left on the bottom. So I may have just went from here over to say, well, I have a 4 on top, my x's on top are gone, and I have y to the 4th on top, and then there was an x left over on the bottom. This is also a good answer, but they didn't have that answer available. So I had to know that x to the negative 1 is really the same thing as 1 over x to the positive 1, or 1 over x. So kind of remember that with negative exponents. If you have x to the negative 3rd, that is really just x to the positive 3rd over 1. So whenever you have a variable on bottom, those are really negative exponents. It's kind of the moral of the story. Number 18 is a little graph problem here. They're talking about the Mars rover and how many social media followers they had. So I guess sometimes I look at the chart, sometimes I look at the sentence to kind of figure out what's going on, but I like to peek at the chart. So it looks like there's age groups. Looks like the most popular age group was 18 to 25, had the most followers on social media for the Mars rover. And then 55 to 65-year-olds were the lowest. But it says the total number of followers on social media account was 1,764,000. All right. So that's a lot of followers following the Mars rover. Which of the following could be the median? So big thing again is, remember, median is the middle number. The middle number. So that means if you lined, and you have to do it from small to big. So if we basically lined up all of the social media followers by age, and it looks like our youngest one was 13, our oldest one was 65. If we lined them all up, we want to know who's right in the middle. Well, to find that middle number, if I lined up 1.7 million followers, I need to divide this by 2, and that'll give me the exact center there. So when I do that and I divide this out, I get 1764000 divided by 2 is 88,200. So whoever follower number 88,200, he represents or she represents the middle person. And remember, we started at 13 years old, so we may have like 13. You may have a whole bunch of 13-year-olds, then some 14s, blah, 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 all the way over to 65. Well, that middle person, let's see where he's going to end up. And since my followers are in thousands, it says times by 1,000. They always do this to trip you up. Kind of drives me crazy, but needless to say, they do it. So I kind of have to wipe out the 3 zeros. And I'm going to wipe this out right here. This was actually 882,000. I kind of messed that up. So not 88,000. 882,000. So when I wipe out the 3 numbers here, we're really talking about person 882 according to the chart. So looking at the chart, you know, my first number over, it looks like we're up to about a little over 250. We'll call it 260 there. Well, then if I add all of these people, that adds, say, maybe another, I don't know, 430, 440. So far I'm up to, if I add those 2 numbers together, so far I'm up to 700,000 people. So it looks like this 882,000 person is going to occur, you know, right over in here somewhere. All right, so I have 260,000 plus another 440. That was around 700. And then I'll be 800, and then 880 is going to be somewhere in this window right here. So it says, which of the following could be the median age? So I need to find somebody within this group, and the only number that really fits into that group is B. A 29-year-old would fit somewhere in there at that halfway point. So that problem was a little bit tricky. There wasn't a lot of high-level math, but just understanding the chart and how to find the median of a bar graph. All right, number 19, we've got a graph here. It says the height in meters of a golf ball t seconds after it was hit is given by a function. A, B, and C are constants, meaning they're numbers. Then they have a graph shown below. So a couple things. First off, this is a function for a quadratic. So you know it's a quadratic basically because the biggest power there is a power of 2. And quadratics, either they're a parabola opening down or they're opening up. And the equation there is written in standard form, but we don't really need all that for this problem. But we do need to understand function notation. So this kind of little line right here basically says that height is a function of time, meaning that time is the input and height is the output. So time is the input number and the height is the output number. So if you just stick in any given time, boom, out pops out the height. We know how high the golf ball is. So at 0 seconds, it had a height of 0. You know, at 1 second, the golf ball is, I don't know, maybe 30 meters or so, 32, 33. At 2, it's up here. At 3 seconds, it's on its way down. 4 seconds, it's somewhere here. 5 seconds, it's getting close to the ground. So we can kind of track the golf ball for any given point. So it says the point P of 270. So we have this random point kind of floating up here. 270 represents the height of a bird at a given point in time. So looks like for the bird at 2 seconds, it is at a height of 70 meters. So that's this bird up here flying. So it says which of the following expressions correctly compares the height of the ball and the height of the bird. So the ball is the blue chart, the bird is the red dot. Well, the first two don't even make sense. F of 70. We don't even have 70 seconds on our chart. All right. So basically that doesn't make sense. But these last two do. So it looks like if we want to compare the ball to the bird, so ball to the bird, well, f of 2 for the bird is higher. The bird is up here and the ball is down here. So f of 2 for the ball is less than that of the bird. So right here, the height of the ball and the height of the bird, f of 2 is less than 70, smaller. Just kind of clarifying that last little phrase. You know, for the ball, I can figure out where f of 2 is. If I kind of go up, you know, somewhere right around in there. So for the ball, f of 2, when I input 2 seconds, I get 60 meters. And the bird, f of 2 was 70 meters. And 60 is less than 70. So that may just be another little piece to help clear up why D was the correct answer for that one. All right, number 20, looks like we have a scatter plot. Size and sale price of houses in some town called H. On the right, we have the house prices again in thousands of dollars, not hundreds of dollars. And then the size of the house in thousands of square feet. So, for instance, just to kind of make some sense of this chart, I'll pick a dot. You know, this dot right here represents roughly a 1,000 square foot house. Costs roughly, if you go over to the right, $200,000. So that's kind of how you interpret a dot on the chart. Square foot on the bottom, price on the side. So the scatter plot above shows the size X and sale price of 25 different houses. Which of the following could be equation of a line of best fit? So best fit is basically a line that goes through the majority of the points. So if I just kind of, you know, I'm not going to do it perfectly, but I think somewhere in this neighborhood, a line looks like it might roughly go, you know, just something like that. There's some points above the line, some below the line, but that line's a decent fit. So it says, which one of these could be the correct equation? Well, the first thing I notice is 3 of these equations have a y-intercept of around 100, which the y-intercept is where you cross the y-axis. Choice D doesn't have one, which is implied that it's 0. I don't see one going through 0. I mean, maybe loosely if you kind of say, well, I'm going to kind of go up like this. I don't think that would be as good of a best fit line. So I kind of would rule that one out, but there's a little bit more way, a little bit better of a way to kind of do this and get some real data. And I kind of want to get the slope. So if I pick a couple points, let's just roughly pick a point somewhere in here that represents, you know, 1,000 square foot house, $200,000 cost. And then I pick another one, maybe right over here. I don't know. This is kind of a good point as well. Maybe right there at a 2.5 thousand or 2,500 square foot house for $350. And now that I have 2 points on my line, I could go ahead and I could try to come up with a slope for that line. That would at least give me which of these first 3 it cannot be if I get the right slope. So remember from an earlier question, slope is basically, you're going to do y2 minus y1 over x2 minus x1. So this was my first order pair, so I'll call it x1, y1. This was my second. So putting in the numbers, we got 350 take away 200 over 2.5 minus 1. And that gives me 150 divided by 1.5, which comes out to be 100. So I think the slope of this line needs to be 100. So that right there wipes out for sure. It wipes out this one and this one. So now we have a decision to make. We have a slope of 100, a slope of 100. But if I choose those 2 points and I connect those with a line coming straight, I don't see any way that I'm going to get all the way down here to 0. So I think just that fact alone, I'm going to say that it has to be B. I think that's the best answer up there. There's more formal things we could do with finding the actual equation. We could use point slope form, but I don't think that it's necessary to go into all that for this problem. All right, number 21. I thought number 21 was kind of one of more of the toughest problems on the test because I haven't seen a lot of work word problems. That's kind of what this topic is called on the practice test. You will find some on Khan Academy. So if you're looking that up, or if you want to Google a little bit more on this topic, and maybe I'll make a video for it, but I don't really see it enough to spend a ton of time on it. But it's a work word problem. And if you Google this topic, there's a lot of different videos and websites that'll come up showing you how to do these. But here's kind of the basic idea. It says Tricia and Stacy each work at their own constant rate, whether they work alone or together. If working alone, Tricia can finish a job 15 minutes faster than Stacy. All right, so Tricia is faster than Stacy. The equation 1 over x plus 1 over x plus 15 equals 1 over 18 can be used to find if it takes Tricia to finish the job working alone, which of the following is the best interpretation of 18? So they're kind of saying, what does this 18 right here mean? You know, what does that mean for this problem? So before I do that, let me kind of go off the grid, and I'm going to explain a concept with these related work problems. So in general, let's say that you have two people. So let's say that you have, person number one. So I'm going to call this T1 is the time it takes person one to do a job. And then T2 is the time it takes person two to do the same job. All right. Well, here's the general equation of what it looks like. If you do 1 over T1 plus 1 over T2, you can do 1 over T, and I'm going to just call this T for together. This is how much they'll do it together. This equation works for all of these word problems like this. So, let's just say that, I'll give you an example. Let's say that it takes person number one. So person number one takes 8 hours to paint a room. And it takes person number two 10 hours to paint the room. Well, and then you want the question is going to be, T sub T, how much is it going to be together? That would be the question. So we can kind of fill in these numbers and we can solve this problem to see, it should be faster. If one person by themselves 8 and the other one by themselves is 10, what if they're both working at the same time together? So here's kind of how you would solve that problem. So you'd have 1 over, the first person I think was 8. So 1 over 8 hours plus 1 over 10 hours equals 1 over X hours. And then you kind of go through and you have to kind of crank this out. So first I'm going to add up these two fractions on the left. I have to get a common denominator. I think the first number they both go into is 40. So I'm going to change these denominators into 40. 1/8 is the same thing as 5 out of 40. And 1/10 is the same thing as 4 out of 40. So when I add those up, that's supposed to equal 1 over X. So 540 plus 440 is 9 over 40 equals 1 over X. And then you can cross multiply here. And you get an equation. You get 9X equals 40. So dividing both sides by 9, it looks like X equals, divide by 9, it goes in there, what's that, 4 and 4/9. So 4.4 repeating hours. So that would be the answer to this question. If one person took 8 hours, the other person took 10 hours, then together they could get that room done in 4.44444 hours. So let's go back to our original equation. This one, the x is in a little different spot because they were trying to find out what Trisha did. So Trisha's 15 minutes faster than Stacy. So this represented Stacy, okay, because and this was Trisha. So we didn't know how much Trisha was. We knew that Stacy was 15 more than Patricia, or just Trisha. So it looks like the 18, that should represent together. So you didn't really have to solve anything. You just had to know how the structure of the equation was built. So the 18 is how long it would take them working together. So that would be, correct answer would be C here, the number of minutes. So that one, you just got to know the format of the question. All right, number 22, very important topic. I would say these problems occur 4 to 5 times per test. So on the real SAT, which is 58 questions, you could expect close to 10% of the test is going to be on systems of equations. 2 equations with 2 unknowns. There are several methods for solving these, and if you follow me through all 8 practice tests, we kind of explore every single possible way to solve them depending on what's being asked, what information we have, how it's set up. So I think I'll show you a couple different ways for this one today. First thing I like to do is I'm going to kind of rewrite these off to the side. And I have 2y equals x plus 40. And then I have 3x equals y plus 20. Well, one common method to solve 2 systems of equations is substitution. So basically what I'd like to try to do is get one of the letters solved, one of the equations solved for a variable. And I don't know, maybe I'll do this very first one. Like, let's try to get this first one solved for x. So I'm going to minus 40 from both sides. And when I do that, I'm going to have x equals 2y minus 40. So I basically just subtracted that 40 from both sides. And once I do that, I can now use this expression right here. Since it equals x, I'm allowed to just substitute it in for x, because that's what x equals. So I'm going to rewrite that equation. And I'm going to say 3 times, and instead of writing x, I'm going to write 2y minus 40 equals, and then I'll finish it, y plus 20. So I just rewrote that equation, plugging in the red phrase there for the x. And now we distribute and solve it. So I'm going to have 6y minus 120 equals y plus 2. Notice that I got rid of the x's. Since I substituted this expression in, the x's disappeared, and now I can solve it. So I have 6 y's on the left, 1 y on the right. I'm going to subtract that y from both sides to gather up all my y's on the left-hand side. So 5y minus 120 equals 2. You could have did 2 steps in one on the one before, but I don't want to lose anybody. So I'm going to just kind of do it one step at a time. And you'll get 5y equals 120. What did I do wrong here? Oh, that was a 20. That was a 20. And that was a 20. So this would be 140. I saw a decimal there, and I figured I probably did something wrong, and I did. And then divide both sides by 5. Divide by 5, divide by 5. And you'll get y equals, looks like it goes in there, 28. Now, don't get all happy and pick 28, because look what they do. They always do that. On a multi-step problem where you do a bunch of work and you get an answer, they put that answer right at the top and they want you to pick it. But if you look at the question said, what is the value of x plus y? Well, I only have y. I got to go back and figure out what x is. Now, I can use any equation I want. It doesn't matter. But we're going to substitute that y value in. So we're going to plug 28 in. So maybe I'll use this equation. And I'm going to go 2 times, I now know what y is, equals x plus 40. So that's 56 equals what plus 40? You could probably do that in your head, but I'll just go ahead and finish the algebra. and I get x equals 16. So now I have x, I have y, and if I need to find out what x plus y is, x plus y comes out to be 44 is the grand total final answer of this question. That was quite a bit of work. You could have also used the second equation here, and you could have minus 20 and solved for y, plugged y in. It really doesn't matter. But that method right there is called substitution. So it's kind of important to get to know the strategies and then the topic of the question. This was a system of equations. So if you're analyzing tests and you're wondering, like, why am I missing certain problems? If you can identify the type of problem, and then you can kind of see, whoa, I missed like 4 of the 5 systems of equations. That's a lot of points. So I might need to spend more time on that one. And I'll definitely have a content video on systems of solutions, showing you all the different ways to solve it. So substitution is just one method. It's not my preferred method. I normally like to use what's called elimination. So I'm going to show that really quick as well. So with elimination, there's a little bit of front end work, but then it seems to be easier once you get going. So I have my equation. I have 2y equals x plus 40. And then I have the 3x equals y plus 20. Well, the main idea for elimination is I like to get it set up to where I have 3 columns. I have x's, I have y's, I have my equals, and then I have my numbers. And I just like to get them set up in that format so that they're matching columns. And that helps me eliminate better. So on this, I'm going to kind of do it this way. On the top, I want to get the x and y on the same side. So I'm going to move this x over by subtracting an x from both sides. And I end up with negative x plus 2y equals 40. And then the bottom equation, to get that one matched up, 3x is already on the left-hand side. So I'm going to put 3x there. But I need to move the y over. So I'm going to minus the y from both sides. And that equals 20. And now my setup is looking pretty good. I have the x column, I have a y column, I have the equals column, and then I have the number column. Now what I'm going to do is I'm going to attempt to get a coefficient. Coefficient's just the number that's in front of the x. So if I have something like 4x, 4 is what we call the coefficient. So I want to get my coefficients to match up, and I may have to multiply a row to do that. So if you kind of notice this top row, I have this is really like right now it's like minus 1x right there. And I want to get it to match up and to be a minus 3x. So I'm going to go ahead and I'm going to multiply this top row by 3. Basically, every piece is going to get multiplied by 3. And I can do that. I don't change the value of all the solutions. I don't hurt the equation at all. So I'm going to multiply and I'm going to get negative 3x, positive 6y, positive 120. And now I've achieved my goal of I have some coefficients that kind of match up. I know there are 3 and a negative 3, but that's going to help me out here in a second. So what I'm going to do is I'm going to eliminate the x's by adding these 2 rows together. So 3x plus a negative 3x is going to make my x's disappear, and there's nothing there. Now when I do my y's, I have a negative 1y plus a 6y. That's going to give me 5y's. And then 20 plus 120. Notice I'm right where I was doing it with the first method with substitution. I get to that exact same point. Divide both sides by 5. And I get y equals 28. And I'm not going to redo the work for plugging in 28. But I take that 28, I plug it in right there. And when you solve it, you figure out x is 16. And then finally you add the 28 plus the 16. And you get 44. So elimination is another method. When you get good at it, I do believe it could be faster than substitution, especially in certain types of problems. But just another good strategy to have under your belt. So again, that one is called elimination. All right, problem number 23. You may not recognize this form up top as well as the other one, but this is the standard form of a line. So standard form of a line. You're probably a lot more familiar with the slope-intercept form, which is really useful for graphing because you kind of know that this letter here is the slope, or the number in front of the x is the slope, and the number here is the y-intercept, which is very helpful. But standard form is a little bit trickier. Now, I can always change standard form into slope-intercept form if I want. So let's kind of go ahead and do that, because otherwise it's difficult to see what's going on. So I have ax plus by equals c, and it just says a, b, and c are positive numbers. So we know they're all positive numbers. You know, and why don't we just, maybe to make it easier, let's just pick our own positive numbers and put them in there. Let's just do that. Let's just call this 2x plus 3y equals 4. All right, I'm just picking my own numbers. They said they could be positive, so let's do it. Well, if I want to get it in slope-intercept form, what we need to do is we need to solve for y, aka get y all by itself. So to do that, my first move is I'm going to minus this 2x from both sides. Now I'm going to be kind of clever how I set this up. What's left here on the left is 3y equals. On the right, I have a choice. You know, and I have this decision to make right now. Looking at these two, I know I can't subtract those because they're not like terms. But I could either write that as 4 take away 2x, or I could write it as negative 2x plus 4. I'm going to choose the latter. I'm going to choose negative 2x plus 4 because it looks more like slope-intercept form, because slope-intercept form has this x part in front and the number in the back. And then my last move is going to be divide everybody by 3 to get y by itself. So my equation is y equals negative 2/3 x plus 1 1/3. Now, which one of the following graphs to the left could be this possible equation? Not the exact one, but possible. Well, some things I noticed. I noticed that if all three of these numbers were positive, look what happened to my slope. I have a negative slope. And my y-intercept is positive. So I'm going to look through these graphs over here and see who has a negative slope and see who has a positive y-intercept. So on this first one, answer choice A, my slope is negative because it's going down from left to right. So I have a negative slope, and its y-intercept is also negative because it crosses below the x-axis. So that can't be it. I needed a negative, this is what I need. I need a negative slope and a positive y-intercept. So it can't be A. B, I think, is going to be our choice, because when I look at B, my pen actually turned off on me. Get this back on. So I think B is going to be the correct answer, because this one has a slope that is negative and it has a y-intercept that is positive. It crosses in positive territory, decreasing from left to right. So this is the right answer. This, just to finish this out, this would have a slope that was positive, increasing from left to right, but crosses the y-axis in negative territory. And this one would be both positive. Slope is positive, y-intercept is positive. So correct answer, definitely B. All right, 24 is really cranking up the heat. Looks like a geometry problem. And I actually have a couple different ways I could solve it. One way I use just geometry. The other way I use trig. So if you've taken trigonometry, you might find that way a little bit easier for you. And frankly, it's just kind of what you see first. I mean, sometimes you see a certain way and you just start rolling with it. But ultimately, I notice I have this right triangle, and you see the little right angle right here. So I know that's 90 degrees. And so I have a leg of 3 and I have a leg of 4, and immediately I kind of recognize Pythagorean theorem that I know that any right triangle, I'll just kind of put a generic right triangle, the two legs are the sides that form the 90-degree angle. The hypotenuse is always across from the 90. Pythagorean theorem says that leg squared plus leg squared equals the hypotenuse squared. And I'll have a content video on Pythagorean theorem because it does show up a decent amount of time, more on the ACT than the SAT, but you still need to know it. So on this problem, our legs are 3 and 4, and we need to know the hypotenuse, which I'm just going to call x. So that would be 9 plus 16, that's 25, is x squared. And to solve that equation, to get rid of the squared, the opposite is to take the square root of both sides, and I get x equals 5. So I'll find out that this bottom hypotenuse here is 5. Now that's one I would just memorize. You just need to memorize. I don't care how it's positioned, but anytime you see a right triangle and you have a 3 and a 4, the hypotenuse is going to be 5. You shouldn't need to waste time on doing the Pythagorean theorem. It's also true that if you multiply everybody by 2, another combination that works is 6, 8, 10. That's another one you might want to memorize. And you can keep going. You could multiply the original triangle by 3 and have 9, 12, 15. And the more problems that you do, the more patterns you kind of see. I'll just point out there's one other one that's worth memorizing, and that is 5, 12, 13. A leg of 5, a leg of 12, a leg of 13 will satisfy the Pythagorean theorem, where 5 squared plus 12 squared is 13 squared. All right, enough Pythagorean theorem stuff, though. Let's get after and try to solve the problem. Let's look at the geometry way first, and I'm going to go ahead and I'm going to give myself a little bit more room, and I'm going to just go ahead and free up some space and draw this one. So we have our triangle that they gave us, and we have an altitude coming down that's 90 degrees, and we have our right angle, and this was N, M, P, and this was 4, and this was 3. All right, well, if you use geometry, actually what happens, and this is just a fact, that the altitude of a right triangle creates 3 similar triangles. All right, it creates 3 similar triangles, and let me show you why. Let's just pretend that, and these angles aren't going to work out right. You'll see with trig exactly what they are. But let's just, for sake, let's just pretend that this was a 30 and a 60, and this little triangle on the right was a 30, 60, 90. Well, because that 30 is part of the big triangle, if you focused on the large triangle, whose already has a 90 up here, if this angle P was 30, that would make this person be 60. And because this is 90, that means this must be 90 because they form a straight line. And if this was 90 up top and we knew that this part was 60, that would make this part 30. So basically we have 3 30, 60, 90 triangles. All right? So this fact, or this kind of theorem, says that the altitude of a right triangle always creates 3 similar triangles. So I could use proportional sides to kind of solve this one. So let's kind of go back and get rid of these angle measures, and let's kind of focus on the different triangles. Well, my ultimate goal is I need to figure out how long NQ is. All right, so who the heck is NQ? And we already established that this big side over here is 5. Well, I could set this thing up and I could say, well, wait a minute. I know that for the big triangle, all right, so for the big triangle, I have a relationship between the smallest leg and the hypotenuse, right? So the smallest leg, which I'm going to call SL, the short leg is 3. Maybe I'll just draw it separate over here so it's a little easier to see. The short leg is 3, and the hypotenuse is 5. So short leg 3, hypotenuse is 5. So I have that ratio. But then when I come over here and I look at this triangle over the medium-sized triangle over here, my shortest leg is right here, and my hypotenuse is 4. So I kind of have this right triangle where my shortest leg is, I don't know, and my hypotenuse is 4. And I can use similar triangles, and I can use a proportion to set that up. So 3:5 in the big triangle as x:4 in the large triangle, or in the medium triangle, I should say. So when I cross multiply, I get 5x equals 12, and divide both sides by 5, divide by 5. And you will get x equals 2.4, which I believe was answer choice C on the original test. So you almost have to kind of separate these triangles and see like who's the small side, who's the big side. Maybe I'll kind of just clean this up a little bit and draw the 3 for you, just so you can see what I'm talking about. So the little skinny triangle on the left, I don't know NQ, but I did know 3. All right, so that was the smallest triangle. The one on the right, this one was X, and this is 4, but I didn't know this section because I didn't know how long, this piece was right here. So that was kind of unknown. And then I took the whole big triangle, and luckily I knew all the pieces for him. I knew 3, I knew 4, and I knew 5. And then I just got to kind of match up and compare the right pieces. And if I put who's who, so in this triangle, 3 is the hypotenuse, because here's the 90. This was the short leg, and this was the medium leg. Actually, I should probably call that the long leg, because there's only 2 legs, small and a large. In the blue triangle, so in the blue triangle over here, so maybe I'll do this. This little guy was the red triangle. And then the blue triangle on the right, well, if I focus on him, and there's my 90, this was the hypotenuse, and this was the short leg. And then if the big dog, I'll make the big dog the black triangle. The big dog, well, he's the hypotenuse, he's the long leg, and he's the short leg. So I just kind of had to find the right combination of 2 of them that I had to know like 3 out of 4. So I kind of used this setup. I used short leg over hypotenuse. So short leg over hypotenuse equaled short leg over hypotenuse. And then I just cross multiplied. And that's where I got my 5x equals 12, or x equaled 2.4. So if you really like geometry, you could set it up that way. But if you're a trig lover, there's a little different way, but you got to know a little bit more math involving trigonometry and inverse of tangent and things like that. So let's kind of go into that one, because I know some kids tried it that way. So we had our triangle, and this came down. You had your 90. We had 3. We had 4. We figured the 5 out. And so some kids did it this way. They said, well, wait a minute. If this is angle P, and this is angle N, and this is angle M, they said we can find out what angle P is. This angle we can find out what that is. And sometimes in trig we call that theta. So maybe I'll use the theta notation here. But using trigonometry, if P is my reference angle, if I'm standing on P, the opposite angle over here is 3, and the adjacent side would be 4. My hypotenuse is 5. So I have a relationship, and if I want to find that angle measure, I could use any of them I want. I like to use tangent. So I do know that the tangent of angle theta is 3/4. Now, if you want to figure out what theta is, you need to use the inverse. So it's kind of like if I want to get rid of that tangent, I do the inverse of this side, and I do the inverse of both sides. It doesn't exactly work this way, but this is how I kind of see it in my head. So I can do the inverse tangent of 3 over 4, and that'll tell me how many degrees theta is. And when I put that in my calculator, I got somewhere roughly 36.86 degrees. So I know in my last example I kind of called it 30, but it really wasn't 30. Now we know exactly what it is. It's 36.86, roughly. I'm going to round it off. Well, now I can use that fact to figure out what x is. Because now if I just focus on this triangle right here, and I kind of redraw that, and I'm like, all right, I have this triangle. And you might remember this from later in geometry, or definitely in Algebra 2. You learn how to use SOHCAHTOA to find missing sides or missing angles. And here's the situation that I have. I have that angle. So this is going to be my reference angle. And looking out across the triangle, this would be the opposite side, and this would be the hypotenuse for the smaller triangle. So opposite and hypotenuse, if you remember SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over the adjacent. Well, we have opposite and we have hypotenuse, so I'm going to use sine. So the sine, when standing on 36.86 degrees, is opposite over hypotenuse. And to get x all by itself, what I basically have to do is I have to multiply both sides by 4. That'll cancel that out. Multiply by 4. And when you punch in 4 times the sine of 36.86, you are going to be extremely close to 2.4. So that's just another way of using trigonometry. But I think the geometry version might have been a little bit easier, but you had to know that the altitude broke the triangle up into similar triangles. All right, number 25, another table. So again, I spoke about this earlier in the video if you saw the other problem. But this problem is called table data. So if you're on Khan Academy, they have some really good questions involving table data under the SAT practice section. I don't like some of their practice problems, but I do like the table data problems. Now this one's going to look a little bit different than on your test, so I'm going to again break this up into a little chart. But I'm sure on your actual test it was probably drawn more like a regular table. And kind of have these numbers here. All right, so 2013 state taxes. So some states have an income tax, some have a sales tax, some have both. So whenever you do these tables, the very first thing I always do is I add up the rows and the columns to find the total states that they were talking about. So state income tax, 36 states have a sales tax. 4 of them have no state sales tax. So that's 43. No state income tax. So there are 6 plus 1. There are 7 states that do not have a state income tax. So most states do have an income tax, some don't. So that adds up to 43 plus 7 adds up to, hey, all 50 states, which is what's supposed to happen here. So I was adding horizontally. I was adding rows to get those numbers on the side. Now I'm going to add columns, and I'm going to focus on these headings. So state sales tax, it looks like 39 plus 6. It looks like 45 states have a sales tax. I know here in Michigan it's 6%. Some states do not have a sales tax. Like I don't think Montana does. I don't think Alaska does. There's 5 of them though, I guess, that don't. And no sales tax, there are 5 without the sales tax. And if you add up going across, that's 50 as well. So now the whole thing here is they're going to ask, they usually ask for a percent or they ask for a fraction, but I need to figure out, the biggest mistake I see people make is they don't know what the bottom number is. So let's kind of let me help you here figure out the bottom number. To the nearest 1/10 of a percent, so I got to round to 1 decimal place, what percent, and this is the key part, what percent of states with a state level sales tax. Okay? Whatever comes after that word of, that is going to be the bottom number. So what percent out of states that have a state level sales tax? Well, a state level sales tax is this column. There are 45 states that have a state level sales tax. All right? So out of the 45 states that have a state level sales tax, so the question says, what percent of states with a state level sales tax, so there's 45 of those, do not have an income tax? So these are the people that do not have an income tax out of the states that have a state sales tax. So 6 out of 45. And now to find a percentage there, I'm just going to divide that out. I'm going to do 6 divided by 45. And, or you could change that. Sometimes I might change that to a fraction. But I'm going to go ahead and just crank it out on my calculator. And that's going to be 0.1333 repeating. So moving it 2 places, it looks like it's going to be 13.3% will be the final answer for that one. So correct answer is C. All right, number 26, just kind of peeking at it, I see some function notation. So whenever I see this f of x, I know there's going to be an input, output kind of situation. So remember, f of x is really just y. And this x number right here, that is the input. And the y is the output. So kind of looking at this chart, let me just kind of break this chart down a little bit. That means that, for instance, if I input x equals 1, so if I have f of 1, that means if x equals 1, well, at x equals 1, it looks like y equals negative 1. And then if I do x equals, let's say, 0, if f of 0, well, f of 0 is a y value of negative 3. And then maybe I do one more. I don't know, maybe I do f of 2. If I do f of 2, that would be right here. If x is 2, then y is 1, 2, 3, 4, 5. So there's some different values that when I input x numbers, I get y numbers out. Basically, they create ordered pairs for me. So they give me the f function on a graph. Well, then they give me the g function with an equation. So I'm going to do the g function. This is going to be my red function. So that one they just give me, a way to calculate it. And then ultimately they want to know, hey, what is g of 0 subtract f of 0? Well, we've already got our f of 0. F of 0 is right here. F of 0 is negative 3. So now it looks like we need to find g of 0, and then we need to subtract those two numbers, because it was g of 0 minus f of 0. Well, let's find g of 0. G of 0 is, you just put 0 in there, 0 take away 1, times 0 take away 5. Well, 0 take away 1 is negative 1, and 0 take away 5 is negative 5. So it looks like g of 0 is just positive 5. So g of 0, take away f of 0, and remember, whenever you're doing integers like that, you don't subtract, you add the opposite, or use your calculator, and you get a correct answer of 8. So kind of a tricky question, but I think once you understand function notation and what it's asking, the math really isn't too bad on it. All right, number 27, I see a couple of equations up there. Ax plus b equals 3x minus 4. In the equation above, a and b are constants. So remember, they say this a lot, but basically constants are they're just numbers that don't change. If the equation has no solution, so this is huge. When does an equation have no solution? Which of the following statements must be true about a and b? Well, I will tell you, no solution occurs when this happens. If I have something like, here's a classic example, x equals x plus 1. if I say, hey, solve that equation, it's impossible to solve that equation. First of all, algebraically, you'll run into a problem. If you try to get all your x's to one side, you'll go minus x, and then you'll have 0 equals 0 plus 1. And you're like, what? 0 does not equal 1. That's not true. When that happens, when all your variables disappear and you're left with a false statement, that's a problem that has no solution. And if you kind of look right in the beginning, there is no x I can plug in to make it true, because the right side is always going to be 1 bigger than the left side. No matter what number I plug in for x, the two sides can't be equal. So basically, the key with no solution is when both sides lose their x's and they have two numbers that are not equal to each other. So what I need to have happen is this. I basically need to have, I have 3x minus 4 on the right. And on the left, I need to have a 3x, okay, because I want my x's to completely disappear. But then whatever number goes right here, it cannot be negative 4, all right? Because if I have 3x minus 4 equals 3x minus 4, well, that can be solved. Basically, any x can work there. No matter what I put in for x, the two sides are going to be true. And because when I try to solve it, and I do that to both sides, I get 0 minus 4 equals 0 minus 4, which is a true statement. And when that happens, you have infinite solutions. All right, anything works. You can stick in whatever numbers you want, and they all work. So I can't have the same number be right here. I need them to come out to be where the two sides are different. So basically what had to have happened to have no solution, my x's had to match. So since they said a is the number in front of x, I got to make sure that a equals 3. Well, that wipes out these two. So a's definitely got to equal 3. But my b number, my back number here, my b cannot be negative 4. Okay? Otherwise, it's going to be infinite solutions. So the one that worked here was B. All right, B is the correct answer for number 27. So key pull away from this is to get no solution, your x's have to be the same, your numbers have to be different. So other examples, just to kind of show you the pattern, other examples of no solution would be like negative 2x plus 5 equals negative 2x plus 4. That's going to be a no solution because the x piece matches, but the number piece does not. All right, number 28 looks like another table involving percentages, so I guess we got to kind of read to see what they're talking about. But we have different genres of video game: action, family, sports, strategy, other, and then the percent of the total sales. So it looks like sports is like the biggest one out there. The table above shows distribution sold by a gaming company in 2010. If the total number of games sold, so that this is going to be important, if the total number of games sold was 250,000, how many of the genres were more than 40,000? All right, were more than 40,000. Well, so whenever you want to find the percent of a total, basically you can just change this percent into a decimal and multiply it by the total. That's kind of the shortcut. So, you know, if action games represent 29% of the 250,000 games, what number is that? Well, it's 0.29 times 250,000, which that one comes out to be, it's like 72,500. So that's definitely more than 40. So there's one that's more than 40. 32% is bigger than 29%. So, you know, I'm not going to work it out, but I know that number is also going to be bigger. So this one has to be. The family one, I'm pretty sure, is going to be bigger. If I do 0.28 times 250,000, That one comes out to be 70,000. So that one's bigger. And I don't think these other ones are going to be. I mean, one way that I know for sure is it's very easy for me to find 10% of a number. If you want to find 10% of a number, you can divide it by 10 or just get rid of one decimal place. So if I move it one decimal place, that's basically 25,000. So I know these two are both under 25,000 because they're under 25%. If you really wanted to figure it out, you could do 0.06 times the 250 grand and 0.05 times the 250 grand. But you're going to find they're both under 40,000. So the correct answer to this is 3. All right. How many of the genres were more than 40,000? There were 3 of them. All right, number 30. We have a graph here. It looks like a scatter plot. Appears to be a best fit line. Number of beach visitors versus temperature. So I guess what we kind of expect is that as temperature goes up, more people visit the beach. So we have looks like a linear relationship according to our line. So each dot in the scatter plot above represents temperature and number of people visit the beach on 11 different days. So each dot represents a different day. The line of best fit is also shown. According to the line of best fit, what is the number of people rounded to the nearest 10? So that's kind of important. Don't pick a number that doesn't end in a 0. It's got to be rounded to the nearest 10. Predicted to visit the beach on a day with an average temperature of 32. So basically, if it's 32 degrees out, how many people are going to come to the beach and round to the nearest 10? Well, my temperatures are down here, so 32 is this line. So if you go all the way up to there. Now, I've had students in the past that what they do is they mistakenly pick a dot that's closest and like use that dot's information. Don't do that. The expected, all right, the predicted number is right on that best fit line. So that dot right there is what we need. So now I need to go straight over. And it looks like 480. So we would expect 480 people to be there on a day where it's 32. You know, if they would have said 35, then I would have went up to 35. I'd have hit that line right there. I'd have went straight across and said, oh, I don't know. What are these going by? Guess it didn't come into play. But it looks like these are going by 40s. You know, 0, 40, 80, 120. So if every block is going by 40, I might have guessed like 660 or something for that one. But the correct answer here was definitely 480. All right, last problem on the calculator section, number 31. Same chart as number 30, but a different question here. So let's kind of focus in on this question. It says the line of best fit, so I'm kind of reading right here. The line of best fit for the data has a slope of 57. So first of all, remember what slope is. In word problems, slope is the rate of change. So it's how much something is changing by. So in this line, remember slope is kind of like rise over run. So the rate of change on this one, my rise is the number of people, okay, and my run is my temperature, all right? So if they're telling me I have a slope of 57, that means I'm getting an increase of 57 people for every 1 degree of temperature increase, all right? So every degree it goes up 57, and we can kind of see that on the chart. You know, I go up to about here, which I can't really see what number that is, but 26 degrees will go over 1 degree, and they're telling me that that number was 57. I couldn't really see it, but they're telling me that. So every time it's like, you know, go up 57 over 1, go up 57 over, all the way up. So according to this estimate, how many additional people per day are predicted to visit the beach for every 5 degree increase? All right. So if we gain 57 people for every 1 degree, then that means for every 5 degrees, I need to multiply this number by 5. So 57 times 5 is going to be 250, 35. So I think there's going to be 285 people if you increase it by 5 degrees. So the correct answer for this question is 285. Basically, you just got to kind of keep the stair step going the same. If it goes up 57 and over 1, then they want to know how much is it going to go up if you go over 5. So you just got to magnify both numbers by 5. So an increase of 280. And we could check that and see, how accurate it is on the graph. I don't think we'll be able to see it perfectly, but we could pick a couple spots. Maybe we pick right here at 80, and then we go over 5 degrees, which would be right about here, cut across. That's somewhere, I think these are going by 40, so 360. So, you might guess and say, well, for 5 degrees, we went up from 360 to 80. I could see somebody guessing about 280, around 280, just if you try to look at the chart. But that 57 kind of locked it in and got me to hone it into a little bit more precise number, like 285. So that's the correct answer for number 31.